Okay, this is the second to the last lecture in the place value series. In this lecture, we shall be looking at some further examples involving decimal place values and its application in writing decimal numbers in their expanded form and in words. Okay, let's go into the example. Example 3. In our previous lecture, we did example 1 and 2. So follow us up from there. Now example 3 says, find the place value of 5 in the number 176.5028. Now let's quickly look at the solution. Using our place value principle, of course here we are using the decimal place value principle because we are dealing with the decimal number. According to the principle, the first thing we have to do is to bring down the numbers. After which we begin to arrange the position. From the decimal points, we have the units, the tens, the hundredth. Then after the decimal point, we have the tenths, the hundredth, the thousandth, and the 10,000th. Now, we are looking for the place value of 5 in the number. You can see clearly that 5 is under what? The 10th position. So, 5 is in the 10th place. It therefore means that the place value of 5 is what? 5/10. And 5/10 means 5 times 1/10. Because 10th means 1/10. So 5 times 1/10, that gives us 5 times 1, which is 5 all over 10. So 5/10 is equals to 0.5. So therefore, the place value of 5 in the number is what? Tenths, which is what? 0.5. Now, let's look at another classical example. Example 4. The question says, find the place value of each digits and figures in the number. Find the place value of each digit or figure in the number 85493.7261. Now you are asked to find the place value of all of the digits there. Now let's quickly look at the solution. Now, still using our decimal place value principle, according to the principle, we first bring down the number and then begin to write their position. Okay, we have here units, here tens, here hundred, here what? Thousand, and here what? 10,000. After the decimal point, we have tenth, hundredth, thousandth, and 10,000th. Now, from there, we can see that 8 stands for what? 10,000, because it is placed under the word, the 10,000 position. So 10,000 means 8 times 10,000, and that gives us 80,000. Then 5 stands for 5,000, because it is placed under the 1,000th position, and that gives us 5 times 1,000, and it is equals to what? 5,000. Now, the next there is 4. 4 stands for what? 400. So, 400 means 4 times 100, and that gives us 400. The next there is 9. 9 stands for what? 9 tenths. I hope you are seeing it with me, because 9 is placed under the 10th position. So that gives us 9 tenths, which is equals to 9 times 10, and it gives us what? 90. Then the next one there is what? 3. 3 stands for what? 3 units, because it is placed under the unit position. So 3 units means 3 times 1, because unity means 1. So 3 times 1 is equals to what? 3. The decimal point there, that stands for decimal points, which is obvious. Now after decimal point, we look at what? 7. 7 stands for what? 7/10, because it is placed under the 10th position. So 7/10 means 7 times 1/10, because 10th means 1/10. So this gives us 7 times 1 is 7 all over 10. So we have 7/10. Then 7/10 gives us what? 0.7. So 7 there stands for 0.7. So the next one is what? 2. 2 stands for 200th, because it is placed under the 100th position, And that gives us 2 times 1 over 100, which is equals to what? 2 times 1 is what? 2 over 100. So 2 over 100 gives us what? 0.02. I hope you are getting along with me. The next one is what? 6. 6 is under the thousandth position. So therefore, 6 stands for 6,000. And that gives us 6 times 1 over 1,000. Because thousandth means 1 over 1,000. So we therefore have what? 6 times 1 gives us what? 6 over 1,000. Then 6 over 1,000 gives us 0.006. The next one there is 1. 1 is under the 10,000th position. So what we are going to have is that 1 stands for 1/10,000th. And that gives us 1 times 1 over 10,000. And this gives us 1 times 1 is 1 over 10,000. That arithmetic will now give us 0.0001. Now, in the expanded form, because we want to show you the application now, in the expanded form, the number that we just finished solving, 85493.7261, can be written thus: 80,000 plus 5,000 plus 400 plus 90 plus 3 plus 0.7 plus 0.02 plus 0.006 plus 0.0001. That is the expanded form. So this is how we write expanded form of decimal numbers. So this can be written in words as 85,493.7261. Please note, immediately after the decimal point, we pronounce, or we call each of the number one by one. We pronounce them singly, one by one. So it is pronounced as 85,493.7261. Some people make mistake by saying 85,493.7261. That's very wrong. Immediately after the decimal point, we pronounce the numbers one by one. Okay, let's give you something to play with. The question says, what does 5 stand for in the number 564.301? The second one says, write in words 222.217. Okay, do that. Comment your answer in the comment space below. Thank you very much. Okay, in the next lecture, we shall be considering place value lecture 7, the final lecture in this series. Here we'll be looking at the difference between face values and place values. So we'll see you in the next lecture. Thank you very much.